This video will demonstrate how to use the standardized and normal distribution formulas in Excel. So here we've got our example problem from the lecture. If x is distributed normally with a mean of 100 and standard deviation of 50, what is the z-value when we know that x is 250? So let's go ahead and type in our formula that's on the left here. So we'll do equal sign, standardize, and it pre-populates so we can just fill that in. Our x is 250, comma, the mean of 100, and our standard deviation of 50. Once you hit enter, we'll get our z-value. In this case, it equals to 3. Moving on to the normal distribution, this first formula here, I've offered it in case we ever needed it, but we don't actually use it in class because recall that false means it's not cumulative, and that will give us our probability density function when x is equal to some exact number. So we won't use it, but I have it here in case you need it for reference. Well, let's go ahead and use our example from class. A population is normally distributed with a mean of 100 and a standard deviation of 20. So here we want to find the probability that x is less than 90, and I'm going to use the formula to my left. So we'll type in equal sign, normal distribution, so that's norm dist, and our x is 90, we'll do comma, our mean is 100, comma, our standard deviation is 20, comma, and it is cumulative, so we'll type in true, and then hit enter. That gives us our probability of x being less than 90 at 0.3085. Let's go ahead and do the next example where we're looking for the probability that x is greater than 130. So the formula we're working with is over here to the left. So since we're doing greater than, we're using the complement that's why we subtract from 1. So we'll do 1 minus, and then norm distribution. Our x here is 130, comma, the mean of 100, comma, the standard deviation of 20, comma, and true for cumulative. Hit enter, and this is our probability that x is greater than 130, 0.0668. Now, say we want to find the probability of x between two numbers. So what we'll do is we'll actually use this much longer formula of the normal distribution twice. So we'll type in x norm distribution, where x, and we use the bigger number first, that's 130, our mean of 100, comma, the standard deviation of 20, comma, true. And then you'll want to be careful and make sure to click outside the parentheses so that you don't do anything funny with our normal distribution formula for the first set of data. Make sure to hit minus and then type in norm distribution again. Here our x on the lower end is 90, comma, our mean still 100, comma, our standard deviation still 20. And then go ahead and type in true for cumulative and hit enter. So now we have the probability that x is between 90 and 130 at 0.6247. There's one more normal distribution formula in that it's the inverse. And so this is when we know the probability, but we don't know the x. So it's like working backwards. So here we'll do equal sign, norm, INV, and the probability that we're given is 0.3085, comma. Our mean is still the same mean here at 100. Our standard deviation is the same from our problem 20. And you hit enter, it tells us that the x is 89.9979. So of course, if we round that, we can see that it equals to 90, which is what we found earlier. So I wanted to show you how these two are inversely related to each other. So that's how you use the standardized formulas and normal distribution. Let me know if you have any questions.